Right, thank you so much. I hope this is audible. Oh yeah, okay. All right, I hope everyone is able to hear me properly, right? Okay, perfect. I hope everyone's having a wonderful day. It's day two, and of course, day one was blast. And thank you so much for the entire team to organize this conference. The topic that I'm going to be covering is the importance of CI/CD in the world of MLOps. And I always like to start my talks with Slido. I hope like everyone has probably heard of Slido. If not, I'll just walk you through. But a quick introduction. I'm Shivay. I flew in all the way from India, and I'm probably only the one from India actually. So that's really great. And I currently work as a DevRel engineer at Millisearch, which is a open source trust-based search engine, and I've also been a Kubeflow release team member. Now, what I wanted to start off with is getting thoughts about this particular session because it has been a bit controversial in the past. And what I'll recommend to all of you is to scan this code. This will redirect you to slido.com, and you can put in that pin code. And the question that I've kind of put up is, what are your thoughts about DevOps and machine learning? Can they coexist with each other? And I just wanted to do this before starting my session to just kind of get to know what the audience thinks about this particular topic. And of course, as we uncover about the concept of CI/CD and how it can be used in the field of machine learning and MLOps, then we'll kind of see what are your thoughts. So feel free to add your thoughts, and you can see that this is kind of a word cloud. So as you add, the responses will be shown up on the screen. So someone says, yes, they do exist. And someone says, I'm learning, I don't know. There's one really interesting answer on hope. So before bots take over, and you never know, bots might take over. So we'll probably just take another like few seconds and see what kind of responses do we get. So a few people are unsure. Some people are saying you need to learn more. But a lot of people also do agree that they do coexist. And of course, the outcome that we'll try to see is that, yes, they can coexist. And they are not actually future. They are being used currently. Like, both DevOps and machine learning can exist currently. And that's what we are going to be covering. So I hope that this kind of gives me a good idea of like the audience. It's kind of a mixed response. So probably let's get started. So one of the misconceptions that people usually have, and this kind of just stems from the previous slide that I also shared, right? So the talk that I'm giving over here, I also submitted the same abstract to 3 other DevOps days, and I got a rejection with a similar feedback from the review committee that ML is a very touchy subject in the DevOps world, and a lot of it feels very artificial and not practical for the normal DevOps engineer. And if we kind of look at 2 sides of the same coin, whether it's data scientists or it is DevOps. So first, let's talk about data scientists. Data scientists typically write the Python notebooks, they run experiments, they write machine learning models, they evaluate the models, they conduct some tests, they might use libraries like Seaborn or Matplotlib in Python in order to generate metrics out of it. But the moment you ask them that, hey, can you help to productionize this model? Because of course, after you have created a machine learning model, the next step is to productionize it, right? So that you can actually use it inside of a ML application, instead of a web application or any other software application. But the data scientists tend to stay away from it, right? They get scared, and they always say that I just want to focus on my Python notebook and that's it. And whereas with DevOps engineers, they don't really like to get into machine learning. They say that they just want to work on their Terraform scripts, or they want to work with CI/CD, and they don't want to learn the nuances of machine learning or the mathematics behind machine learning. And of course, given the fact that both DevOps and machine learning appear to be very vastly different fields, it does raise that question that, hey, I mean, are they interrelated, or can we really combine both of them together, right? So, of course, I mean, I just shared some memes to kind of make this more interactive. But the idea is that what I'll try to uncover today is that, yes, you can very easily integrate CI/CD or GitOps or DevOps very easily with your machine learning pipeline. But of course, for those folks who might be new, because of course this is a DevOps conference, so if you do not come from a machine learning background, I'll very quickly just run down the entire machine learning lifecycle and how that kind of looks like. So usually you start by defining a problem, and you collect your data related to that particular problem. So for example, let's say a problem statement could be what's the effect of COVID over the past like 2 years in city of Raleigh. So you'll have data points such as like, what has been the number of cases that have been there over the past like every day for the past 720 days. And then once you collect your data, you clean your data, because of course you never have data in a very direct to use format, right? So you clean your data, you define your model parameters on the basis of which you will do your feature engineering, basically picking up most important parameters inside of your data set that will be used for doing the model training. Then you train your model, and finally you get your predictions and your results, right? So that's the typical machine learning life cycle. And if, of course, the predictions are coming out to be fine, then you will go ahead and deploy your model. And if we just talk about the ML code, right? So about the entire ML system, the ML code is actually just not even like 5% of your entire technical depth that is there for your entire ML ecosystem. So whenever you're talking about any machine learning or MLOps system, we are talking about data collection, we are talking about the feature extraction, things related to the infrastructure, like to set up the infrastructure to actually host and run your machine learning models, because typically your machine learning models require GPUs, and you might require multi-clustered GPUs to be able to run some of these machine learning models that are requiring a lot of compute. So the actual machine learning code, which is like writing your machine learning model, is very minuscule part of your entire machine learning systems. And this is where the power of DevOps really comes into the picture, and that we'll actually see. So whether it's like monitoring your model once it has gone into production, or it's actually setting up the infrastructure for being able to actually run your machine learning inference. So what I try to say is that as development requires DevOps, similarly machine learning requires MLOps, right? And if you understand that what MLOps really is, MLOps is a set of tools and practices that apply the same principles of DevOps that is applied to dev, but to machine learning. And machine learning itself, right, is very similar to your software development in terms of, as we'll see that how, like, by taking some examples of CI/CD, you'll see that how replicable it is to be able to write those same set of scripts that you write for CI/CD for standard software, to be able to replicate them for being able to manage your machine learning models. So whether it's like, testing your models and then deploying your models, right? So that's what really I want to convey from this particular talk. Now, of course, that's just to kind of break down into the three major aspects of how CI/CD is primarily used in machine learning. So when it comes to your data, right, because data is the king for machine learning. If you have the right set of data, then of course your models and the training that you do for your models will go out pretty well. So whether it's like checking whether the data itself is accurate, doing data version control. So very similar to how you do, you use Git to basically version control your entire code base. You can use machine learning data, like CI/CD data, for being able to ensure that whether the experiments that you're running, whether they are running on the correct set of data or not, right? Then when it comes to training, you'll be finding use of CI/CD within model training as well. So whether it's like, choosing what type of algorithm to run, then selecting what kind of parameters should be required in order to optimize your machine learning model. And then when it comes to deployment, that's also a very important place where your CD principles will be used for model deployment as well. So whether it's like, you have to deploy your model to production, or you want to make a canary release with the new set of model parameters that you have just added. Because one of the typical use cases that you'll see is that, let's say as a data scientist, you create a machine learning model, it goes into production. Now, one very important thing is that when you work with a model in production, the amount of data that you are adhering to, right? Because you might have users from all over the world. So there might be a lot of hidden edge cases where your model actually might start to fail. So what, as a data scientist, you'll be required to do is you'll be required to make incremental changes in your model as your model goes into production. And once you have made those changes, you have to also test the efficacy and the efficiency of the model after you have made those changes. And then you have to push it in production. Now, if you were not to use something like CI/CD, it would be a very tedious process, because of course, again, you're making these changes in your model, then you have to manually deploy them to production, test it in production. And this cycle for doing all of this in a non-automated way will require a lot of time and effort, and also money for your DevOps teams. So that's where you'll find a lot of use for CI/CD. And I just wanted to also cover this particular diagram. So this diagram is from Google Cloud, which kind of, I hope it's visible to everyone, but in case it's not, I'll be sharing the slides at the end. But what you see over here is that first thing that we are doing is we are doing data analysis, where we are just ensuring that the data itself, whether it's good or not. Then we are doing the model training. Then we are pushing our model into production from the source repository, and we have our entire pipeline set up that allows us to automatically manage our data versioning and then pushing our model into production. And if we just kind of break down now the different steps, so of course the first thing that every data scientist starts off with is writing a Jupyter notebook, right? As a machine learning engineer or as a data scientist, we are always writing these Jupyter notebooks. Now, Jupyter notebooks are great for doing experimentation and running your inference, right? But there's no direct way of being able to directly just take your Jupyter notebook and put it into production, right? So what you can do is there are a lot of different tools, and one of the ones that I personally worked on is with the help of, for example, you could use Jenkins to break down your entire cells within your Jupyter notebooks as separate Jenkins build tasks, and then automate that with the help of your Jenkins pipelines. Then when it comes to, let's say, your entire machine learning pipelines, there are tools like Kubeflow that allow you to automate that. Then, for example, if you want to integrate CI/CD unit tests or integration tests, you could use platforms like Jenkins or DVC, which is like an open source data version control system that I'll also be showing in a couple of demos. Then, for example, if you want to do the delivery, that's mean like whether you want to have a canary release or you want to deploy your model into production in any of your clouds, then you can use tools like Spinnaker, which is an open source continuous delivery tool that allows you to actually do that. And this kind of showcases that, for example, you make certain changes in your configuration file and you can run some smoke tests, or let's say if you want to go ahead and trigger, you detect new model changes, so your CD system can automatically determine what are the model changes that have taken place and directly go ahead and either create a canary release or directly push it into production into any system that you might be using. And this kind of showcases the entire example that I kind of demonstrated with those 6 samples. So what you see is that when you're making any code change in your machine learning system, Jenkins or DVC for that matter can detect those changes, push those into the continuous training cycle where you are basically doing your machine learning inference on the new set of data that you're training on. And once you have seen that, okay, whether the tests that you're running, whether those are good enough to be pushed into production, then you can use CD systems for doing your deployment. And of course, the use case that, as I mentioned, right? So this was the first use case that I personally got to work on. This is the Jenkins machine learning plugin. If you're interested, you can check it out. That's the link for so it is actually part of the Google Summer of Code project in 2020, where you basically take your Jupyter notebook, add a custom kernel to your Jenkins so that it can detect an IPython kernel for the Jupyter notebook, and then take all of your different tasks, whether it's the feature extraction or model training or model evaluation, and have those as separate Jenkins build steps. And it can automatically generate reports and logging for you with the help of the entire Jenkins pipeline. And the other one that, of course, that I'll be demonstrating right now is that how you can very easily do things such as your model evaluation and training directly with the help of GitHub Actions. And that's what I'll be showing in my demonstration as well. And of course, the other one that I also mentioned earlier was related to DevOps, which is similar to how we have Git for being able to manage your or version control your software, right? Similarly, it's really important to also version control your data as well. So the use case over here is that, for example, you write your first ever line of machine learning code and it works well, you push it into production, and it worked on a certain set of data, right? Now, of course, as your model kind of grows, there might be some changes that you might make in your input data set that was initially used, right? And you might have different versions of your data set. So it's also important to track that what type of model evaluation was done on what specific type of data, right? What type of input data? Because of course, data within any space of machine learning plays a really important role. So with the help of DVC, which is an open source data versioning tool, you can keep track of what particular type of input data was used and the corresponding evaluation that took place with that particular set of input data set that you have. So essentially, if you're running multiple experiments, you might have, like, let's say 3 or 4 different versions or iterations of your dataset. You could very easily just maintain a log of those datasets and the corresponding model evaluation that had taken place with that particular dataset. So that you can very easily manage that with the help of DVC. So coming on to the demo, right, I have prepared 2 separate demos. One is a very simple, straightforward demo that I'll run, and the other one is actually taking your dataset, pushing it into an S3 bucket on AWS, and then running your inference from there. So before I move over here, and this will be part of my second demo, but let me first go to my first demo. So I hope everyone is able to see the screen. Is it? Oh, okay. I'll make it bigger. All right. Perfect. I hope that now it's visible to everyone. Perfect. So over here, it's a very simple example where I have just used sklearn, and I'm using a random forest classifier to do my model metrics. And what I've done is over here, first let's go to the GitHub workflow, because this is an example for a GitHub action, right? So if you want to work, if you have not worked with GitHub Actions is a set of CI/CD tools that are provided by GitHub. And in order to create a new GitHub workflow, you just have to create a repository. Within your repository, you have to create a folder .github, and then within that, you have to create workflows, and then you define your YAML file to be able to run that particular workflow. So in this case, if you see over here that I've created one workflow over here for model training. And what it will simply do is that it will go ahead and use the iterative setup CML. So CML is basically an open source tool for continuous machine learning. And this provides you very easy to use CI/CD pipelines for your machine learning projects directly in GitHub. And I'll be sharing the link for CML as well at the end of this talk. So over here, what you'll see over here is that we will use the GitHub action for the setup CML, which is basically setting up our CI/CD pipeline for our GitHub action. And we'll simply just go ahead and we'll run our train.py, which is our Python package over here, our Python module. And we are simply just going ahead and running our machine learning model, generating the accuracy score and generating the confusion matrix. So for those who might not be aware, what is the confusion matrix? It's basically a diagram that allows you to share like how many false positives or how many false negatives did you actually generate. So that's simply what I'll be doing over here. So as next steps, what I'll do is that if I go back to the CML, right? So what it's doing is that it's basically generating the logs, and it's generating a plot which shows the confusion matrix, right? So what I'll do is I will go ahead and check out to a new branch, because what we'll do is that we'll see the confusion matrix getting generated on the generation of a pull request, right? So that's what we are going to be doing. So if you see over here, the action that I've done is that it will be an on push, and when I actually generate a pull request. So let me check out to a new branch, and I'll just call it test 3. And within this branch, what I'll do is that I will change the depth of my random forest classifier. So I'll change it to 7, let's say. And let me go ahead and push my changes now. And I'll go ahead and push my changes. All right, perfect. So let's go to my example over here, and let's go to my pull request, and actually go ahead and create a pull request. Now, as soon as I create this pull request, it will automatically start to trigger a new GitHub action. So let's particularly see. Okay, my bad. I probably set up a different one. Let me go ahead and make some new changes. Just a minute. Let's say I add the depth as 9. I'll go ahead and just make these changes. What I wanted to do is actually run it on my own system. So let me probably change the repository, like the branch. Let me move back to main, and then just run the steps again. Just 1 minute. Just call it test 4, and go ahead and run the same changes. All right, so once I've done that, I will go ahead and create a pull request. So let me go ahead and create a pull request, but for my own repository. So let me do that. All right, so as soon as I create a pull request now, it will go ahead and start to trigger a new workflow. And this is basically the UI for the GitHub Actions. I'm not sure if everyone is able to see it, but you can see that now the action has started to run. So right now what it's doing is it's running the iterative setup CML, which is basically setting up the GitHub action for doing the continuous machine learning. And it probably does take another like few seconds, and then we should be able to see the confusion matrix getting generated within our pull request. So the idea over here is that as a data scientist, when you want to push your model to production, before doing that, you would want to test whether the performance of your model is good or not, right? And you might be doing this for multiple machine learning model changes that you're making. And what you can do is that you can set up your continuous integration for your model changes to ensure that, yes, the changes that you're making actually make sense, and you can see that directly in your pull requests. So if I go back to my pull request now, I should see a new confusion matrix getting generated, as you can see, and it also actually prints what's the accuracy of the model changes that you have made alongside the confusion matrix. Now, I think we are running slightly out of time, but the other demonstration that I wanted to showcase was it goes a bit deeper into being able to push your model changes into production, like into an S3 bucket, let's say. And the idea over here is that, let's say if you have a new model, you will upload that model to a remote storage. It could be an S3 bucket or any other cloud, and then you create a pull request. It automatically spins up a new GitHub action, and if the changes that are there, if they are good enough, you can go ahead and merge those particular changes, right? So over here, what you'll see is that I have this run test, and what this does is that within this particular GitHub action, so this is a separate project, and I'll be happy to share the code with all of you to kind of follow along. So over here, what we're doing is that we are first creating a pull request, and on the creation of a pull request, you'll not just be able to actually test your model. So within these steps, you can see that it will install the dependencies, it will pull the data and the model, and over here it will pull that from the remote S3 bucket where you are storing your model, and then it will run the test with PyTest. So PyTest is a testing suite in Python to be able to run tests. And what you'll see over here is that we have written tests for testing the model as well, to check whether the inference of the model is correct or not, whether there is any data drift or prediction drift that has taken place. So as compared to your last time, what has been the total amount of change in the prediction result inside of your model, right? So these are your proper test cases that you might also write for your software as well, right, in a typical software sense. So you can run these tests directly and then also go ahead and evaluate your model as well, right? And it will finally then go ahead and create a report for you. So as an example over here, like this was one of the tests that I just ran, where so the model that I was running was basically a SVM, which is a support vector machine learning model. And over here, I made some incremental changes to my model. And what you can see over here is that it automatically triggered that particular pipeline, and it generated again the accuracy of the model and then some other parameters like hyperparameters that you can see over here. And to kind of see like how that particular action looked like, so it is basically this one, which is the change SVM kernel. You can see over here that this is the entire workflow where it first goes ahead, installs the dependencies, runs all the different tests that we have written, right? So whether it's like running the tests on your processing of your data or the actual model itself, right? And the evaluation of the model. And then it will go ahead and evaluate the model, and it will create those reports for you. So that is the use case that you see that, right? As with any DevOps project, if you're running it on a normal application, you'll write your code, you will build the code, you will run your tests on the code. If the test pass, only then you will go ahead and push your code into production with a CD system, right? And that's what we are seeing over here, that you can very easily replicate those same principles, but for a machine learning workflow, And again, whether it's version control or whether it's testing your code with machine learning, it's very relatable to your standard software, right? So as I go ahead and end this, right, I'll go ahead and run another poll. So I'll request all of you to scan this particular code again. This is a separate poll. And the question is that if you're not already convinced that CI/CD is for machine learning, I hope that you're convinced now. So if you can just simply answer this poll, it would be really great. So if we get even like one yes, I mean, I think like that would be great. But yeah, I mean, the main demonstration that I wanted to showcase is that it is as simple as like, doing CI/CD or DevOps that you do with your standard software development processes to replicate that directly with ML, right? And the great thing about ML right now is that as these tools for MLOps, they increase, right? They become better because of course MLOps is still something that's new, and it has been there for the past like few years, and it's a growing field, right? So the tools that are being used for MLOps are also growing at the same time. I was just having a discussion with other folks from the conference that OpenAI, they are today being like how they're able to run is that they use Kubernetes and they have multiple 500,000 plus clusters with their running GPUs and all the machine learning inferences taking place on those GPUs. So they are extensively using MLOps, and a lot of different teams that today are having AI-based products or they are using machine learning internally are utilizing the same set of DevOps tools or similar set of DevOps tools that you might use for your DevOps use case for a normal software as well, right? So I think 88% is it's a pretty good number to kind of take a validation that yes, everyone does agree on that particular fact. And I'd like to conclude with some resources. So feel free to take a screenshot of these resources. So primarily one of the ones that you see over here is by Sayak Paul, who's an MLGDE, and the one that he covers is basically how you can set up CI/CD for your machine learning systems, but with GCP, which is like Google Cloud Platform. Right, and going back over here, the other ones that I covered are CML, which is basically your continuous machine learning that provides you GitHub Actions to be able to automatically generate test cases for you and do the model evaluation with the help of your GitHub Actions. And the one that probably I'll recommend to everyone is this mlopsguide.github.io. This kind of walks through each and every step of how you can create your own GitHub project, set up your GitHub Actions, and of course, you can replicate this for other CI systems as well. So whether you're using Circle CI or any other internal CI pipelines, those should work pretty well, similar to how we showcased the demonstration for GitHub Actions. And yeah, that's it. I'll be open to questions now. And if you want to connect with me, you can connect with me on my Twitter @howdevelop, and I'll be open to questions now. Thank you so much.
Let's see if there's any questions. Does anyone have any questions? Oh, yeah, sure.
Nobody asked questions. So for this type of CI/CD pipelines, one thing that I've heard is a people trying to have problems with the data movement of models are not like 1 meg files that you move around, or these models are a large amount of data. So what are kind of the latest tools or modern tools to deal with, or maybe practices of not moving the data, leaving the data in the cloud, leaving the data in the test, caching, those type of things? These are something that I've heard in the past, maybe a few years ago, that was the part that was difficult, but also costly.
I +1 that question. Last time I looked at this was a challenge.
I was going to try to save you from running. That's fine. Yeah, so as you might have seen that I had covered the tool like DVC, right? So which is like data version control. So that actually does play an important role in being able to manage your data. So of course, transaction of the data or moving your data around can be an expensive affair. So whether it's being able to make incremental changes to your data or having different versions of your entire dataset, and those dataset could be in gigabytes of size or petabytes of size. So DVC as a tool can very easily do that data versioning management for you. So whether it's like you're hosting your data remotely on an S3 bucket or any other S3 compatible or S3 compatible data store, so you can very easily just manage looking at whatever latest changes have been made to your data, or very easily just refer to that particular data set with the help of DVC. So that's of course one tool, but that's one of the most popular open source tools that are there that can very easily handle that.
Yeah, thank you. So maybe I missed something, but did you try to look at this situation from the different angle? So in DevOps, we have a huge amount of data. We have the metrics from the deployment, from integration, monitoring. So finally, it's a huge amount of data. Can we use machine learning to analyze this data and create predictions? So what the benefits we can use from this approach? So did you try to look at this idea from this side?
Yeah, so I think that's the beauty of machine learning, right? That of course the use case that I kind of covered was that how DevOps is useful for machine learning project, right? So when it comes to deploying your machine learning model or making those incremental changes, and then of course I didn't really cover things such as Prometheus or Grafana for doing like observability on your machine learning model predictions as they are being run in production, right? So other one could be that a lot of DevOps teams use machine learning for anomaly detection. Or of course, as you generate these logs, you could use specific machine learning models to see how these logs are getting generated over time and try to generate some insights from that so that it can actually help you improve your DevOps process as well. So of course, like applications for machine learning can be applied to that entire DevOps pipeline that you're running for your model training and pushing into production, and those can be used to optimize your DevOps principles like that you're using.